We think of plants as stationary organisms. They're rooted in place, but really plants are in constant movement. And you can see that if you look outside on a windy day and you see their branches moving. Even if they look like they're still, there might be tiny movements of the ground from nearby traffic or distant earthquakes that are subtly shaking that plant. Or there could be an insect walking along the plant. Any kind of mechanical force in the environment causes plants to move and to bend. And plants can also sense virtually all of those movements.
So we use this model plant of Arabidopsis, and we can record the vibrations that the caterpillars make on the leaves when they feed. Now these are very tiny vibrations, they're very hard to see, and this is something my collaborator Rex Cocroft is an expert in. He will use a cold laser to measure the tiny deflections in the leaf by the feeding. And then the second important thing that he can do is that he can play back those vibrations in the absence of the caterpillar to make the leaf move just like it would had a caterpillar been there feeding, but there's no caterpillar.
And in subsequent experiments, we've even found that just vibrating a plant the way a caterpillar would when it's feeding, but with no attack, no other stimulus, the plant can increase its defensive chemicals against caterpillars. And there might be reasons why we would want to make a plant think that there are natural enemies around, because maybe we could have the plants defend themselves in advance of being attacked.
You can imagine all kinds of practical applications because insects are pests on the food we try to grow. And so there are lots of opportunities for others to take what we've learned about how plants respond, detect and respond to vibrations, and use that to design technology to use in the field to control insects.
And that ability of plants to defend themselves has been shown in a lot of studies to be very effective. We might be able to work with the plants in a sense to give them cues in advance that they may have enemies around. So it might be able to help us grow plants, for example, with fewer pesticides. That's out in the future. We'd like to see the work go that way. Again, our own work is really focused on just the basic hows and whys of plants and the sounds that they're detecting and responding to.